apply sandwich theorem to evaluate this limit. Okay, so this can also be done by using L'Hopital rule, which will be much easier, but the question was apply sandwich theorem. Okay, so we're gonna do that. So first of all, evaluate the left hand limit and the right hand limit. Okay, so first we're going to evaluate the right hand limit. Okay, now, so for the right hand limit, we are taking x. So for the right hand limit, we are taking x in between 0 and pi by 2. Okay, so now in this region, it's sin x greater than x greater than less than tan x. Okay, so it's this thing satisfies in this region. Okay, sin x is less than x less than tan x. Okay, now we are going to divide each of the term by sin x with sin x. So then it will become 1 by x by sin x less than 1 by cos x, where x is in between 0 and pi by 2. Okay, now watch carefully. I divided each term with sin x. Okay, which is where x is inside this region 0 and pi by 2. Now you can see the graph here of sin x. Okay, now for every value between 0 and pi by 2, you can see that the graph is the value of sin x is positive here in this region. So it's positive, so we are dividing each term with a positive term, so the inequalities are not going to change. Okay. So now as we have taken x greater than 0, so limit of x tends to 0 plus of 1, this will be 1 obviously, and limit x tends to 0 plus of 1 by cos x. Now 1 by cos x, that means 1 by cos 0, which will be 1. Okay, so now by sandwich theorem or squeeze theorem, so now this function, limit x tends to this function is 1, and limit x tends to this function is also 1. So then by sandwich theorem, what we can say that limit x tends to 0 plus this function will also be 1. Okay, so limit x tends to 0 plus x by sin x, this will be 1. So the right hand limit, so this is the right hand limit. Now we are going to evaluate the left hand limit. Okay. So let me erase this and this part here. So now, okay, so now for the left hand limit, what we will take is this, where x is in between minus pi by 2 and 0. So x is in between minus pi by 2 and 0. So now in this region, what happens? Sin x becomes the greater one and tan x becomes the smallest one. Okay. Yes. Okay. Now so now we are again dividing each term with sin x. So this will be 1, this will be x by sin x, and this will be 1 by cos x, where x is greater than x less than 0. Okay. So now notice carefully, here the inequality changes. Okay. Why so? Because uh, x for x in between minus pi by 2 and 0, you can see in the graph that for every values between minus pi by 2 and 0, the value of sin is negative here. Negative inside this region. That's why, like, we are dividing each term with a negative term, so the inequality will change. Okay. Now same as before, limit x tends to, here it will be 0 minus, as x is less than 0. Okay. 1, this will be 1, and limit x tends to 0 minus of this function cos x, this will also be 1. Okay. So then by sandwich theorem, what do we get? The same limit of this function will also be 1, of x by sin x, this will be 1. Okay. So now we get both the left and right hand limits. So let me erase this first. Now what we're gonna do is okay, so now the left hand limit, this is of x minus sin x, this is 1, which is also equal to the right hand limit. So we can say that limit of x tends to 0, x by sin x, this is 1. So now limit x tends to 0, sin x by x, this will be 1 by 1, which will be 1. So value of this is 1.